In this video, we're going to talk about how to solve problems involving direct variation. So direct variation happens when the relationship between x and y can be described by the equation y equals kx, where k is a number called a constant of variation. It is said that y varies directly with x if this relation is true. So let's examine these two functions. The first function, c of g equals 2.12 g, represents the total cost c of g gallons of gasoline. The second function, the function c of p equals 1.28 p, represents the total cost c of buying p pencils. What do these two functions have in common? Well, let's look at these. In both functions, we have two variables, right? So here we have c and we have g. So we have two variables, and then here we have c and p, and then we have those two variables being related by a constant. So we have a constant factor on one of those variables, okay? Because that constant is being multiplied. That's why I'm calling it a constant factor. So an equation where we have something like this going on is an example of direct variation, right? Because we said that we'd have two variables, y and x, and then we'd have this constant of variation that relates the two variables. So these two functions are examples of direct variation. So direct variation actually does occur in many real-world situations. Anytime you have two variables that are related by a constant factor, you actually have an example of direct variation. So for example, if you're modeling the cost of buying P pencils, if each pencil costs $1.28, you can write an equation saying C of P equals $1.28 times P. If you're modeling the cost of buying G gallons of gas, if each gallon costs $2.12, you can say C of G equals 2.12 G. The total weight of X objects, if each object weighs 4 pounds, we can write a function that says W of X equals 4X. If we're talking about the total distance traveled after 8 hours of driving at a speed of 45 miles per hour, we can say that D of H equals 45H. So you can see there's a lot of different situations that we can model using direct variation equations. So let's look at some examples. Marcy makes $14 an hour for each hour she works. Her total pay, T of H, varies directly with the number of hours H that she works. Write an equation to represent this direct variation relationship. So when we've been talking direct variation, we said direct variation is y equals kx, and the phrase we had is y varies directly with x, okay? When we're talking about these word problems, we won't always be talking about y and x, but this is going to be like the version of the phrase that we look for. So here it says her total pay varies directly with the number of hours H that she works. So what we can do is we can say that this means that T of H, okay, which kind of took the place of y, equals k times the number of hours, which is H. So now we need to figure out what is this value of k. Because remember, k is going to be a number that represents the constant of variation. Well, she makes $14 an hour, so that means 14 is like the rate, right? 14 is the rate of change. So we're going to use that to replace k, so that means we have the equation T of H equals 14H. So let's try this example. Marco is building a block tower with his little sister. The height of the block tower varies directly with the number of blocks used. When 10 blocks are used, the tower is 20 inches tall. I'm going to first do part A, write an equation to represent this direct variation relationship. So here is my important phrase. It says the height varies directly with the number of blocks used, okay? So if I translate that, that's going to say height equals some k times blocks. Well, in this problem, it doesn't tell me which variables to use, so I can just make up my own. I'm going to call height H, and I'm going to call blocks B. So that tells me that H of B equals K times B. Well, now I need to figure out the value of K. It doesn't really tell me that I have a rate of change in this problem. It just gives me an example, right? It says when 10 blocks are used, the tower is 20 inches tall. Well, since I have this equation, I can use that to figure this out. 10 blocks is telling me that 10 equals B. 20 inches tall is telling me that 20 is the value of H of B. So I can plug into my equation that I wrote and figure out the value of K. I can say that 20 equals k times 10. So I can do the opposite of multiply by 10 and divide both sides by 10 to figure out the value of k. So 20 divided by 10, which is 2, equals the value of k. So my equation will be h of b equals 2b. And that is my direct variation equation. Now I'm going to do part B. Okay, so I have my equation from my previous slide, h of b equals 2b, and I'm going to use this to determine the height. So when you're trying to figure out h, with 15 blocks are used. So 15 blocks means that 15 equals b. So I'm going to figure out the value of h. h of b equals 2 times 15. So that means my value of h equals 30. And the units in this problem are inches. So I'm going to say 30 inches. So in this problem, it says your distance from lightning varies directly with the time it takes to hear thunder. If you hear thunder 10 seconds after you see lightning, you are about 2 miles from the lightning. So in problem 1, it says write a direct variation equation for the relationship between time t and distance d of t. So here is my important sentence. Distance varies directly with the time. Okay, so that means that distance equals some number k times time. Well, in this problem, it tells me which variables to use. So distance is going to be d of t, and that equals k times time. So I don't know my value of k, but it does give me an example. It says 10 seconds after you see lightning and you are 2 miles away. Okay, so that means that 2 miles is my value of d, and 10 seconds is my value of t. So I'm going to plug into this equation and use that to figure out the value of k. So I have 2 equals k times 10. So now to solve this problem, I'm going to need to divide both sides by 10. So I'm going to divide this by 10 and this by 10. So 2 divided by 10 is going to give me 0.2 equals k. So my equation will be d of t equals 0.2 times t. So now let's use this equation to solve this problem. If you are 4 miles away from lightning, how many seconds after seeing lightning would you hear thunder? So once again, I have my equation d of t equals 0.2 t. 4 miles tells me a value of distance. So it's saying that d of t equals 4. Find the value of t. So I'm going to plug into this equation and I get 4 equals 0.2 times t. Now to solve for t, I need to divide both sides by 0.2. So I'm going to do 4 divided by 0.2, which gives me the value of 20. So 20 equals t. So 20 seconds would be my answer for this problem.